So hi Andy, how are you doing?
Hey, Sarbjeet, I'm doing really well. It seems like months. This pandemic is just compressing time, but it's great to see you again.
I know, great to see you. And after this is we are recording this after the conference from you guys, and a lot of great content there. It was great seeing you there during that week. Let's talk about what I heard there, and for my audience and for your audience from Splunk side and other people who are not even Splunk users yet. We want to educate them on what you guys do, and then we'll stay mostly at the problem domain. I always say that talk about problem domain more than solutions. We're not going to keep this. This won't be vendor promotion kind of thing. So we're going to talk about concepts. So on that note, in today's talk, I think if we can touch on the need for some standards in the data management space. It can be like data from IT ops, or it can be data from the business operations, right? So we want to cover that. Uh, to start with, I think if we can cover the challenge the hybrid operations, hybrid IT poses in the management of that sort of those environments, and the need for having that data available to organizations. Like how does IT hybrid IT sort of multiplies this problem of management through data?
Yeah, this is a really good question, Sarbjeet. When you think about going to cloud, it's not an either or proposition at the moment, at least. Some new businesses are able to do cloud native for everything. Most businesses that I talk to are hybrid in some way. So the growth of cloud, the challenge is really about connecting. It's also about complexity and volume of data, variety of data, velocity of data. The three V's of big data. We've spoken about that before.
Mhm.
Um, and so what you see in a cloud environment, in the old world of monoliths, you could do a bunch of stuff, and we did a bunch of stuff because of that environment. I have this whole thesis that when developers and operations didn't like each other that much, it wasn't personal. It was because of the cost of compute. Um, so developers didn't put tracing into their applications because that used bandwidth and used extra processing power. They didn't put a lot of logging into their applications because that used storage and processing power. In monoliths, that was important because that cost a lot of money. Cloud computing changed the economics entirely. And so what we get is the challenge is connecting this old world to the new. This is where we're working on the idea of the hybrid approach to data management, a hybrid approach to monitoring, where you connect on-premises and legacy systems, traditional systems, with these brand new cloud, microservice, cloud native systems. Because for most of our customers, they're not disconnected. They're actually connected. Your accounts payable, or maybe your billing system is in the back end, but your customer engagement systems and your website are on the front end. They're still talking. It's still one service you're providing to your customers. When you provide that service, it's on you to make sure it's working. Your cloud provider is not doing monitoring for you. You have to do that yourself. So managing these systems, old tools don't work because they aren't tuned to this complexity, the big data three V's, to the microservice cloud native environment, to the 24/7 everywhere global commerce. And so that's what we're trying to do, is bring that all together, make it easier, faster, more efficient to be able to run stuff in a hybrid model, not just cloud, not just traditional.
So when I look at the cloud, if I want to explain that to any techie, right? I usually say it's infrastructure as code. What that means is that we're not doing the infrastructure traditional way. Rack, stack, pull the wires, and then do it that way. But we can write 3 lines of code or 10 lines of code and get a server, right? And get a load balancer or message queuing into the application with a few lines of code. So what that means is it gives us a lot more telemetry data about the infrastructure in the cloud, which we didn't have earlier. We had that sort of tack on solutions like appliances, like which will look at the TCP packets and sniff packets and find out what's going where, right? You know
Yeah.
that whole old world, right? So I think is that your understanding as well, that we have a lot more telemetry data now available in the newer breed of applications as compared to old? And then
Absolutely.
how can we leverage that if that is true in your
Yeah, Sarbjeet, this is absolutely true. And this is all part of my thesis that traditional systems aren't up to the task, because one of the things that changed when we went from these traditional systems to the cloud was the use of semantic logging and observability. Right. So I used to be in IT ops. You could always observe systems if they provided you enough data to do that. But
yeah
as I said, historically, it was, developers would put debug and logging and semantic logging and metric submission and stuff into their application during QA and test to see if it was working, but they'd rip it all out when they threw it over the fence to ops. DevOps changed all that, cloud changed all that. So now we have developers who work proactively with operations to operationalize their applications and services even before deployment. And part of that means making sure you're ready to monitor that system on day one. And so one of the biggest changes, actually two I'll hit. One is rise of semantic logging. This is just logging that has meaning. And using that, you probably remember you turned verbose logging on every now and then, right? Just to see what was going on. Storage is cheap, Sarbjeet. So verbose logging is on all the time now. So we can observe what's going on. This is what observability is, by the way, is just observing what's happening on the inside of a system using the telemetry that it exposes external. So now with telemetry, I can see the log statements of the application. What is it doing? But not just performance. You mentioned packet sniffing. This is one of the multiple areas I call faking it in the old way, right?
yeah
Sniffing packets, synthetic transactions, simulated users, these sorts of things. Really important when applications don't support direct observability themselves. But if your application is logging and emitting metrics and you're able to look at trace data, you know everything your application is doing, down to things like payload. And so you can see this customer bought this product at this amount. They spent 12 minutes waiting to hit the trigger on the purchase now button. They spent 20 minutes on our site looking at other stuff. When they came to our website, they bounced out and went to another website, then came back. So now I've got user behavioral understanding. I've got product feedback loops. I've got monitoring and performance data directly from that service, not from these fake signals. It's a fundamental difference.
yeah I read a lot on innovation and all this stuff. I'm all over the place. I studied economics in college, and I'm doing computing for the last 25 years. I'm like like I try to mix all these things up, and I always say this, like as I'm getting older, I think I'm like absorbing all this sort of knowledge from all these different sources. And the gist of my one segment of my study is that the what is the difference between high performing companies and the lower performers? I believe the high performers do experimentation at higher pace, and they do that based upon the feedback loops.
Yeah.
That means they use data coming from the field. Data doesn't have to be like bits and like the ASCII format and all that. It can be interviews. It can be uh, getting social signal from social media. You name it, right? So and your systems, of course, like what they're telling you. So I think on that note, there's no denial that the feedback loops are super important. uh, the better, like well-oiled machine you have on feedback loops, the better your margins are, the better your business is, the better better your customers like you, the better your brand is. I mean, it's like you can't put enough emphasis on that. On that note, as a vendor being in this space, do you guys guide uh, at industry level to people like how they can leverage um, this new paradigm, if you will? As you said, the storage is cheap, but on the application side, how they can weave in the intelligence into application through logging? Maybe logging uh, is a very, like, I think logging can be a umbrella term, but by saving this intelligence into certain database, you can, it doesn't have to be file, right? It can be any kind of database, right? So
Yep.
by having that intelligence when you're writing that application and then leveraging that, like, do you guys provide those guidelines, or you guys talk a lot about that? Like, where can people find that information if they are they start up or they're writing new applications? Even big companies, like, how can they retrofit their applications when they are refactoring these applications to leverage that?
Yeah, it's tough, right? Because you all of a sudden go to an environment where there's so much more volume and complexity, new concepts, abstractions. You mentioned infrastructure as code earlier on. There's also other things, right? We're actually seeing things like data as code,
Mhm.
machine learning as code.
Yeah.
Historically, we would provide things like SPL, the search processor language, but now we're providing things like SQL, just using structured query language to hit that data, right? It's all about making it easier for people to get value out of the data they've got. The research that we've done, and we did some really deep research with Enterprise Strategy Group late last year, where we looked at how much data people collected and what their success rates were in terms of things like innovation, stock price, revenue, customer satisfaction, which you mentioned just now. And we found that it wasn't strictly the more data you collected, the better your numbers were in all of these metrics, but the more data you used and the more data you shared. So this is where we really want to provide that ease of use and fast access to collaborate around data. This delivers significant results according to the empirical research. So if I can, I'll just give you an example
Mhm.
in IT operations or in DevOps, for example. So we think of data science as difficult. We think of using data as, challenging. And humans are really bad at data, by the way. Mostly, we have some exceptional data scientists, but most humans not so good with data. We don't deal with pattern matching very well. We don't deal with complexity or volume or velocity very well. So using machines becomes really important. So out of the box, we're trying to provide these machine learning capabilities. So throw your data at a system, in my case, obviously Splunk, but a data analytics system, and then start to get insights out of individual data sets, out of correlated data sets, bring more data sets in. And if you can use predefined algorithms for some simple stuff like anomaly detection. So I
Yeah.
throw a month's worth of event logs or sys logs into the system. And I look at what's normal. I tell the system, I train it what's normal, what's abnormal. Then I give it novel data and ask it to tell me what's normal and what's normal. And then I just have to check yes, yes. Then I can operationalize that data and the algorithm that goes with it. So it doesn't have to be that hard. You can do all the data science if you want, with machine learning, build your own algorithms, plug them in, use them. But we believe that it's important to provide out of the box machine learning and AI capabilities that deliver that value straight away. So yeah, it's tough to work with these new data forms and data sets. They're coming from new locations and new sources, partners, APIs, function as a service, platform as a service, as well as infrastructure as a service. They're coming from on premises as well. It's a hybrid model. Much more data. It's often hard to get a handle on when you're moving to these environments and these new systems and new processes. So providing value out of the box is one way that we can get IT ops and businesses generally using data, using machine learning, using AI to deliver significant value to their business really quickly.
That's awesome. Actually, the idea behind my question was to I mean, like, I look up to folks like you individually. You talk a lot about these developments and where we are headed and all that, like thought leadership, and uh, and also the vendor you represent, right? Splunk. And I also ask this, people who are listening from other vendors and or customers, like we look up to you, vendors like you, to define these things and give us the know-how to the greater industry, if you will. Like this is a better way of doing it because you have the vantage point, because you know that how people are using your tools, and then who is using it more cleverly than others. You can give us a lot more intelligence on this, and then how we should sort of write applications going forward, because you have that intelligence. I think that was my idea behind that question. And what you touched upon there actually is the rebuttal I usually have with folks, like that. I believe the data science or ML is more effective when people are deeply, experts in their domains, right? But when I say that in that context, what I mean is it's on the business side. When you're doing machine learning on transactional data, business transactions and stuff like that. But when it comes to machine data, because there's consistency, the things with machines is they're consistent. They're not like humans. Like
Yeah.
we have that drawback as humans, that we're not consistent.
Yeah.
Like I don't say the same thing again and again. The machine talks same language again and again. If you are getting an operating system log or some kind of data from a system, it's written all the time like same way. Especially the lower you go in the stack, the more consistency you find, right? The higher up you go, the less consistency you get, right? You get my point. So um so i I actually expect the data models which are trained by vendors like you, a data model sort of marketplace from you folks, not the ML built into your application. Everybody says that we have it, you guys say that too, but I want you guys to give the, like, kind of open sourcing that ML models, if you will. Like this is how you train this type of machine data, these type of logs, because they're consistent, because they can used by the wider sort of industry. So I'm like, just long-winded question with a lot of statements. Well, I want you to shed some light on that. What are the developments in that area you guys are doing at Splunk, and what do you see in the industry? What's happening?
Yeah, when you say Sarbjeet, the point of you get the best results out of your experts. I absolutely agree. Data scientists, computer scientists, you definitely need those sorts of people to create your algorithms and so forth. But the big question is, are you writing algorithms or using algorithms? I would posit, if you're an in-business user, you don't want to be writing algorithms, you want to be using them. You want the limited volume of highly technical, competent resources to create the algorithms and then get leverage and scale by letting all of your business users use those algorithms in ways. So I absolutely agree with you. So I believe that we should write some of the algorithms and our customers should write some of the algorithms. So we use algorithms out of open source databases, out of Python library and so forth. So you can add open source algorithms into the system. You can also, using a machine learning toolkit and the simple machine learning environment, as it's now known since .conf, we can enable people to write their own. But we also absolutely provide out of the box capabilities based on our expertise as a leader in the industry and a thought leader in the industry, because we talk to our customers all the time about what's important. And so we can do things like anomaly detection. You talk about machines producing the same thing over and over again. We see that a lot in IT. We see that in security. We see that in IoT. These ideas of an alert storm. One component fails or one entity fails, and it cascades that failure to 100 other entities, which all issue 100 different alerts. And all of a sudden, I've got 1,000, 10,000, 100,000 alerts. And as a human, I cannot deal with that. So out of the box, we're providing things like event correlation to be able to understand, well, which event was, for want of a better term, the root cause, or at least the proximate cause, or one of the proximate causes. I can ignore 10,000 alerts if I know that one source alert is the one I need to pay attention to. That's the sort of thing we do out of the box. And there's a lot of other stuff there as well in terms of, threat analysis. What does a threat look like? We're a cloud software provider. So providing systems that provide monitoring and so forth for cloud, also for securing cloud systems by understanding what is anomalous and what is not. These are the things we provide out of the box. You can still add your own, you can write your own, you can download ones that are already written by someone else, but you've got to have that value out of the box. So we're using telemetry from our customers, we're using our own research teams, and we're using our own knowledge of best practices to build all this into our solutions.
That's awesome. And another thing, actually, usually preach to the technology providers and or service providers is that I usually say that, like, to outcompete your competition, you have to out educate the market. So in that context, also I'm a big proponent of the vendors, or I like the vendors who are developer friendly. What are you guys doing in this sort of industry, in this segment of the industry, uh, to be more developer friendly? Like any SDKs or anything like that? You guys are pushing out,
Yeah.
and then what lies in the near future? That's one part of the question. And the second is, in that similar context, is like, um, the role of the practitioner, like what they can do, how fast they can learn, apply machine learning themselves, which we touched on a little bit earlier. How they can sort of leverage it better. So developer and practitioner in more generality, if you will, non-developer also.
Yeah, so I think it was Stephen O'Grady of Redmonk many years ago talked about the developer as the new kingmaker. And it's so true. We see that business units, just like they did 20 years ago with IT in general, business units are taking on developers to write bespoke code for that business unit.
Yeah.
It's a shadow IT motion, it's a cloud motion, it's an agile and DevOps motion. But what it means is the developers are much closer to business goals and are being asked to do stuff directly with analytics to achieve those goals. We're seeing developers get involved with using data analytics to understand customer engagement behaviors and customer behavior patterns. So using the log and metric data, trace data from the applications to understand and to observe, if you will, the activities of customers, and being able to do that and program their code to tell them when things are going right and wrong. So that feedback loop for DevOps is a very big part of what we're looking at in development generally. And obviously the site reliability engineering partnership of developers and engineers, that it's hard to extricate those two teams from each other in a good DevOps environment. Other things we're doing, absolutely, APIs and SDKs. Absolutely. You can do most of everything in Splunk through a API, through a command line, where you will have seen at .conf, we released actually new software solutions directly aimed at helping developers do things like log analytics. Should be simple. And without a solution like ours, it's sort of hard. But for developers, accessing through an API, log analytics and machine learning driven outcomes, and embedding that into their software using our SDKs and APIs. The other area we're working a lot at is the whole DevOps and incident response. So who responds to an incident when it happens? In a DevOps mode and an agile mode, one of the tropes, developers carry pages, right? So the developer needs to be on call. So matching the right developer with the code that fails in the system that fails, and getting just the right people to swarm rather than do this old 20 people in a war room. These are some of the things where we're bringing it back to the developer to be able to use Splunk in their code, connect to Splunk with add-ons and other sort of collectors, and then leverage Splunk to do their own monitoring, diagnostic, and incident recovery. So these are some things where developers are getting engaged. And just quickly, we did talk about ML and IT ops and AI ops a little bit and stuff like that. And yeah, what we're doing there for more engineering-oriented operations teams, they can write their own algorithms, of course, in the simplified machine learning environment. They can use languages they know now, like SQL instead of SPL. If they want to get really deep, they can go into a unique language like SPL, but they don't need to. They can use out-of-the-box knowledge that we create and provide with our solutions. So things like ITSI, IT Service Intelligence, providing built-in event correlation algorithms so that you can get faster value out of that capability when you install. So yeah, for these advanced operators, they can do advanced techniques, but if they're working, especially if they're working closely with development as a team, there's all sorts of stuff that just comes straight out of the box to get them up to speed with data and analytics and machine learning really quickly.
Yeah, actually, I think that is the key. Actually, the accessibility, like how easily you can start. I think that the vendors which do great are the vendors which are very accessible. Like I can easily spin up services. That's why Amazon was successful with cloud as compared to others. It's not like other companies don't have smart engineers. It's just like, are they opening the doors for people to come in, and how easily you can start tasting some stuff, right? That matters a lot. We the topic of this discussion was the standards, and we are touching upon those mostly. There's a common thread in our talk. You guys are doing some cool work in the open telemetry standard, which I believe um, it's very close to my heart. I think the if you can't create standards, your technology can only go so far, because standards increase interoperability, portability. In hybrid environments, you need that. If I want to excuse me, go from one cloud provider to another, like if I have to rewrite my logs or how I read them, like it's going to be mess, right? And how do I monitor these applications, the metrics, the logs, the traces, those three different type of telemetry data. So just high level, we're short on time, so briefly shed some light on the standards bodies you're involved in and the work you're doing, and how important that work is, and how it helps our industry actually.
Yeah, so this is actually super important to us at Splunk. We're heavily involved in open source and have been for a long time. Not just contributing to it, but we use it internally ourselves as well. We've been the number one contributor to this new area called open telemetry, or sometimes called OTEL. It's where open census and open tracing came together. It's a set of APIs. It's a single set of APIs, libraries, agents, collectors. And what it does, it captures distributed traces and metrics from the application and sends it somewhere. In our case, it sends it to Splunk, of course. Yeah. So having that open capability means that you can work better with partners. You can work better across cross-functional boundaries in your company, different departments, different teams. You can collaborate, centralize, and work together. And again, I believe in this so deeply with DevOps, Agile, that collaboration delivers better outcomes. In fact, our research has shown collaboration over data, especially, delivers better outcomes. So to be able to use open standards and open source, things like open telemetry, but we also work with things like CollectD and StatsD, other open methodologies for collecting data from other sources, and all in one environment as well, by the way. You can mix and match. It just makes it easier to deploy. You can leverage the knowledge your team already has in those open standards and open source components. You can work better across boundaries. And I think ultimately you deliver better value using open standards like OTEL.
Yeah, actually, when you said boundaries, actually, at some point in future, we'll talk about like the data sovereignty issues, like the server sitting in Europe versus server sitting here. How do you sort of mine that data? Are there any implications around that? So Europe has different regulations, and we have different regulations in US. It's country specific, it's region specific. I think we'll go into maybe in the future discussions around those kind of topics, which are kind of semi-political, semi-economic, semi-technical. So great talking to you. We'll wrap up here. Any departing thought you have for my listeners? How do how can they get in touch with you and your brand, and how they can start tasting some of the services you guys provide? Are there any sort of evals and all, anything you can tell them to start playing with this stuff?
Absolutely. So to start with, my final thought is that sharing is caring, Sarbjeet. When you have this data, we have research data that proves this. Multiple sets of research from the Enterprise Strategy Group, my personal research that I conducted alongside partners at Puppet in the State of DevOps report, shows that sharing really makes a difference. Working together and collaborating over data-driven decisions delivers better outcomes. There's just no doubt about it. So sharing is caring. Use data, collect more data, and collaborate with that data. As to how you can get started, absolutely go to splunk.com. We have there, start with some case studies and just stories about other customers that have done some stuff. There's so much good content there in our case study library. You get to learn from your peers and understand what's possible. And then I would say have a look at some of our own self-run data assessments. So the ESG, the Enterprise Strategy Group research that we did, we actually came out with a data value calculator. So you can figure out, where's my data, what does it cost, what's it going to return to me, so I can start to figure out what value I can get from that data. And then absolutely click that button that says, try it now, get Splunk, I think it is. It's a free download, a free trial. You can use our cloud version, so you don't even have to install anything. We've got data in there that you can play with as well. So especially if you're a developer wanting to deal and learn things like machine language and machine learning, jump online, get a quick run through Splunk, play with the simplified machine learning environment, play with our machine learning toolkit, and try it out, because you'll find it's not as hard as you think it is to get started and deliver that value.
Yeah, and thanks to you folks and the platforms like yours, which has made it easier for people to start leveraging that data coming from machines to make better business decisions. So thanks, Andy, again. I always have fun talking to you, and I'm looking forward to talk to you again soon. And happy holidays to you and your family, and to the whole Splunk family, and everybody who's listening, by the way. Thank you again.
Thank you, Sarbjeet. It's always a pleasure. I really appreciate it. Always fun to talk to you. Sometime soon we'll have to figure out how we can get to a conference and meet up in person again.
In person, have dinner or something. Yeah. Thank you.